Hello everyone, I welcome you all for the video lecture on the Python programming language. The topic that we will discuss for today in this class is function composition and recursion for building elegant solutions. Two fundamental programming concepts. Master function composition for cleaner code. We need to understand recursion for elegant problem solving. It unlocks modular, reusable, and efficient designs, and it embraces functional programming styles. Hello everyone, I welcome you all for the video lecture on the Python programming language. Today, we will discuss the topic function composition and recursion for building elegant solutions. Here, we will explore two fundamental programming concepts and master function composition for cleaner code. We need to understand that recursion for elegant program solving is essential, and not only that, function composition unlocks modular, reusable, and efficient designs. It embraces functional programming styles. Function composition, the building blocks, combine functions. Simple functions merge into complex ones. We need to think as modular components. Readable code, composition improves code clarity, it makes logic easy to flow. Data pipelines, data transforms like an assembly line. Each function does one step. Imagine if a complex function contains um, many equations, then, for example, if we have addition, subtraction, division, etc., in a single code of function, then we will do the calculation as in the hierarchy. Yes. So simple division of a complex function has to be done initially, and then individual function has to be checked for its calculation, and then the result combined will be the output printed. Yes. So composition, function composition means we need to merge the complex one, um, dividing it in simple forms, and then readable code. Composition improves code clarity. It makes logic easy to follow. And data pipelines, data transforms like an assembly line. Each function does one step. And then function composition, practical applications, data processing, chain operations like filter, map, reduce. It builds powerful pipelines. UI rendering, it connects data to components. It renders a complex user interfaces efficiently. Mathematical operations, it composes functions for calculations. Example, square, absolute x. So we need to initially do absolute x, and then we need to square value of absolute x. So this is one form of function composition. And web frameworks. Express.js uses middleware chains. It processes requests step by step. Function composition, the advanced concepts. Currying. Functions take arguments one by one. It creates specialized functions. Piping chaining. Data flows through functions left to right. It simplifies transformations. Functional purity. No side effects enhances composability. Functions are predictable. Recursion, self-referential solutions. Function calls itself. It solves problems by breaking them into smaller, identical subproblems. The case, the essential condition that stops the recursion. It prevents infinite loops. Recursive step, it calls the function with a modified input. It moves closer to the base case. Recursion use cases and considerations. Common uses: factorial calculations, Fibonacci sequences, tree traverses, depth first search, and advantages: concise. It is elegant code for recursive problems, and then it gives expressive solutions. The disadvantages: potential for stack overflow, deep calls consume memory. Recursive function, recursion, optimization, and alternates. Compilers optimize this, it reduces stack usage, and cat results for speed. It avoids redundant calculations, and often more efficient. It uses loops for non-recursive problems. The conclusion: the powered DO, clear data flow, function composition for organized data transformation, problem decomposition, recursion for elegant self-referential solutions, powerful code, right declarative, maintainable, and robust software. Let's come to the conclusion. So we are in the end of today's session, and I thank you all.